Hello students, welcome back to CLARI Concepts, Unleashing Conceptual Learning. Today in this lecture, we are going to solve the numerical examples of hydrostatic force on the curved surfaces. Again, I request you, if you have not visited our lecture on theoretical aspects of this particular topic, go and look at that lecture first and then come back to this lecture to solve the numericals. Otherwise, you will not be able to understand how numericals are being solved. So let us move ahead. The very first numerical we have is compute the horizontal and vertical components of the total force acting on a curved surface AB, which is in the form of quadrant of a circle of a radius 2 meter as shown in figure. So we have this figure, we have this around solid surface, solid boundary and the fluid filled within that. AB is a section which is of quadrant of a circle, so it is 1/4 of the circle with a radius of 2 meter, right? Take the width of the gate as unity. So when I say width means perpendicular to the board, the distance, the gate has a width of 1 meter, unity. So now, this is the free surface and 2 meter is the distance given to us, right? And it is also given that the free surface, the point A is lying 1.5 meter below the free surface of water. And now what I need to do? Simple. Solution. Just look at the steps. Firstly, figure out which section are you aiming at. So I'm aiming at section AB and I want to know the force acting on this section AB. Yes. So what you will do, mark the endpoints, mark horizontal line and vertical line from the endpoints, and then figure out the pocket of fluid filled between these two planes as well as the curved surface. So if you take this outside, you will see something like this. Very simple, isn't it? Now, mark all the forces. See, on this fluid element, you will have forces from the upside on this plane. So, you can say that this is, let's say, force Fx, hydrostatic force Fy in vertical direction. And then by the reaction of the surface, you will have, let's say, Fh and you will have Fv in vertical direction. And then the weight is W. Now, you find out all these three forces first and then you use the equilibrium equations to get the value of Fh and Fv. So first I will go by the values. What is Fx? Fx is the force on this plane. This plane has 1 meter width and this is 2 meters of height, right? A plane of 1 meter width, 2 meter height. First you look at the center. Center will be exactly at the midway of this 2 meter. So this center will have the total depth of how much? 1.5 plus 1, that is 2.5 meter. Isn't it? So Fx will be equals to pressure at the centroid point into area. Pressure at centroid point over here is P0 is 0 plus rho GH. So this will be rho of water. I think it is water, right? Let me see. Nothing is given to you. You can assume it to be water. Rho of water G and H, that is 2.5 into area. Area will be what? Area will be 2 meter into 1. Yes. So let me put the values. Rho of water is 1000, G is 9.81, H is 2.5, area is 2 into 1. So calculate the value of Fx, you will get 2.5 into 2, 49050 Newton is the value of Fx. So you got this. Now you find out Fy. Fy is what? Fy is the force acting in downward direction on this plane. This plane has the area again 1 meter and this is 2 meter because this is a quadrant. So if this is 2, this should also be 2. So this length is also 2 meters. Right. Now area is 2 into 1. But the pressure at centroid will be somewhere over here only, na? Centroid. Centroid is lying at 1.5 meter of depth. So pressure at centroid into area, simple. Pressure at centroid is what? Rho of water, rho 9.81, that is G, and H is 1.5. What is area? 2 into 1. Simply do the calculation. See, I hope you are understanding this, right? You will get 29430 newtons. This is Fy. What is weight? Weight of the fluid filled in this particular pocket. That will be mass into G. What is mass? Density into volume into G. Density is 1000. What is volume of this particular segment? Say this is 1/4 of the circle. So can I say pi r square is the total area. If you do pi r square by 4, you will get this area. So this is pi r square by 4 is the area into the perpendicular distance, that is h, or you can say width L, that is 1, right? 1 meter is the distance, and then g. So weight you will get, I'll put over here, weight you will get is equals to 1000, that is density, into pi r square by 4. Pi r is 2 meters, 2 square by 4, into length is 1 meter, into g is 9.81. So you are calculating the weight. So this is cancelled directly, 2 to the 4 and 4. So this is 1000 into pi into 9.81. You will get 30819.02 newtons as the weight. Now when you got all these three, now easily you can find. See, first you will do summation of forces along x to be equal to 0, for example. When you say x, that means horizontal direction. This implies you have two forces in horizontal. You take Fh to be positive, right side, minus Fx to be negative, equal to 0. So Fh is exactly equals to Fx, which is equals to 49050 newtons. Similarly, you talk about Fv, summation of forces along y equals to 0. This implies you take positive upward. So that means Fv is positive, Fv minus W is downward, and minus Fy. Minus Fy is equals to 0. So Fv is equals to W plus Fy, which is equals to W is what? 30819 plus what is Fy? Fy is 29430. So that means plus 29430. I will get Fv as 60249 newtons. So this means the horizontal force is 49050 newtons and vertical force is 60249 newtons. That means this segment, if I now draw you this segment, just a minute, if I draw this segment over here, AB, so AB, the forces that you have calculated is on the fluid element, but the same forces but in opposite direction will be acting on this AB. So FH will be like this, opposite to what it is acting on fluid, and FV is acting on upward direction on fluid, but it will act in downward for the segment. But the values will remain same. So FH is this answer, FV is this. So I hope you got the answer. Let me check the answer. 60249, okay, perfect. And then F 49050, perfect. So I hope you got the answer. Let us take another example. Let us look at another example to get more clarity. Figure shows a gate having a quadrant shape of radius 2 meter. Find the resultant force due to water per meter length of the gate. Find the magnitude of total force acting on the gate. See, you have been given a different category of gate. This is the quadrant given to you. Here is the water. So let us say this is segment A and B. So you just draw a horizontal line and a vertical line. Now you got the pocket of water, right? It is said that from this axis, this is 2 meters and this is also 2 meter, quadrant of a circle. Now find out the total force acting on the gate. So this section, if you see total force acting, if I solve it here, section is something like this. So horizontal force is FH on the segment and vertical force is FV. But when you take the pocket of water outside, you will find something like this. So this water element will, the surface will apply FH force on water element opposite to what it is on the surface, and FV over here, and this will have Fx for example, and this will have FV. Also you will have weight. Now simply you calculate all the values. First of all, Fx. Fx is the force acting on this plane at the midway. Why midway? Because I am looking at the pressure. So what is the centroid of this particular surface? This is 1 meter in length, right? Per meter it is asked you, per meter length. So this perpendicular length of the plane is 1 meter. This is 2 meter. Centered will be at 1 meter. So pressure at centered over here will be what? Force will be, pressure is rho G H into area A. Simply what is rho? That is density of water 1000. G is 9.81. H of C will be 1 meter. 1. Area is what? Area is this area of the plane. 2 meter into 1 meter. 2 into 1. Calculate the value. 9810. Directly I am doing it. This is 19620 newtons. Fx I found. What is Fy? Fy is the force on the bottom plane. Right? This is Fy. What you will get? The center will be located at 2 meter distance. So when you calculate Fy, Fy will be equal to rho GH. Rho is 1000. G is 9.81. H is 2 meter. That is centroid location. And then area is 2 into 1. So I think you must get, you got 39240 newtons. This is Fy. Now the critical aspect is what? Weight. Weight will be equals to mass into G. Mass will be equals to density into volume into G. This weight will be equals to density. Volume will be equals to cross-sectional area into perpendicular length into G. What is area? Now can I say area? This area I want to know. So what is this? It is the square area minus this area. So if I deduct the area of this particular quadrant from a square area, I will get this area. So what I will do? Area that I am looking for is, let's say 2 into 2. So I will do 2 into 2 minus, this is pi r square by 4, fourth of quadrant, right? So pi, what is r is 2 meter, pi r square by 4 is the area and length is 1 meter as it is. G is 9.81 and you can replace this rho with density 1000. So this is what? You can cancel this out 4. So your remaining is, put the value of density 1000 into 4 minus pi into 9.81. So let us calculate. 1000 into 4 minus pi into 9.81. You will get 8420.97 newtons. Once you got W, Fx and Fy, you have almost done all the calculations. How? See, now let me show the equations. So what kind of equations it should be? If I talk about the calculations, firstly I will say on the horizontal line, Fx is equals to Fy, right? Fh, right? So what I will do? I will put summation of forces, summation of forces along horizontal direction should be equal to 0. So in horizontal what forces I do have? Let me just draw it over here again, once again. Right, so if I draw the element of fluid, it's like this, Fx, Fy, W, Fh and Fv. So in horizontal I have Fx to be positive, Fh to be negative to be equal to 0. So I will take Fh on the right hand side, Fh is equals to Fx and that is equals to what? Fx की value क्या थी? What was the value of Fx? 19620 newtons. 19620 newtons. I got one value, one component, right? Fv is equal, now see, summation of forces along vertical to be equal to 0. In vertical what forces do you have? Fy, W and Fv. Fy is positive, W is downwards or negative, Fv is downwards or negative equal to 0. You take Fv on the right hand side, Fv is unknown to you, that is Fy minus W. What is Fy? Fy is 39240, 39240 minus what is W? W is 8420, 8420 newtons, for example, just leave it newtons right now. So this is 39240 minus this. So Fv is coming out to be 30819 newtons directly. Right? Fh and Fv is known to you. So now you found that if I have this section, so on this section, force applied by the fluid is Fh in this direction, Fv in this direction, and resultant is this. This is Fv. And Fr is this. So what is the value of Fr? Fr will be equals to under root of FH square plus FV square. This is equals to under root of FH is what? 19620 plus what is FV? 30819. So this square plus 19620 square, and under root of answer you will get 36534.3 newtons. This is your answer that you are looking for. Magnitude of the total force acting on the element. Let me check the answer. 36534. Perfect. So this is the correct answer. Now let me take you to one of the complicated problem. And now I want you to solve this problem. Okay. But I'll just give you the hint of how to solve this problem. Find the magnitude and direction of a resultant force due to water acting on a roller gate of cylindrical form of 4 meter diameter. So I have the dam and I have the roller gate, and there is a water filled up till this particular height of the depth, right? Now this is said to be 4 meter of diameter, 4 meter diameter. Now when the gate is placed on the dam in such a way that water is just going to spoil, so water is going to spoil on top of the gate, take the length of the gate is 8 meters. So this length of the gate is 8 meters. Now you are supposed to find out what? Magnitude and direction of the resultant force. How will you do that? Firstly, you need to know where is the force applying. So the contact point of gate and water is this arc, this particular cylindrical surface, right? Now if I draw the what do you say? As I said, find out the end points, draw a horizontal line and a vertical line. Do you find any pocket filled? Nothing, no pocket is filled. So what will you do? I will suggest you what you should do is, in this kind of cases, what you can do is you have to divide this surface into two halves. So let us say this is surface number 1 and from here to here surface number 2. So now what you do is you just solve it as it is, as what we were doing so far, but just take this surfaces outside. So now when you solve something like this, you will have one pocket over here. So you have one pocket like this, right? Surface number 1, and one pocket like this, surface number 2. Now you can easily have the forces. Let's say this is 1, so this will be your Fx1. This will be, there is nothing on it, but let's say Fy1, then Fh1, Fv1, and then W1. Similarly, you will have Fx2, then you will have Fh2, Fv2, and then you will have this Fy2 and then W2. Now see what will happen. You solve for these two cases. You will get what you will get. You should get the values of Fh1, Fv1, Fh2 and Fv2. Now look at very closely. I am drawing a section of gate. So on this particular section 1, the Fh1 is acting on this side, Fh1. Fv1 acts downward. Similarly, on another portion of the gate, Fv2 acts upward and Fh2 acts on right hand side. Now when you will calculate, you need to find the resultant horizontal force. Total horizontal force Fh will be equals to, both of them are on same direction. So since you have taken the component, you will directly add because they are both in same direction. So you will say total horizontal force on the gate will be equals to Fh1 plus Fh1 plus Fh2, right? Fh1 plus Fh2, and total vertical force. Now see, since this is at the larger depth, the vertical force on this arc will be larger than the vertical force on this arc. So but both of them are opposite. So you know that this will be larger value. So you then find out Fv is Fv2 minus Fv1, net force. So let's say this is 50 newtons, this is 100 newtons or 80 newtons. So 80 minus 50 will be net force, 30 newtons, right? This is Fv. So once you got Fh and Fv, you can find out resultant value of the force, which is equals to Fh square plus Fv square. And then once you got this, you can find out the angle. So see, Fh is this, let's say, Fv is this, let's say, and the resultant force you will have an angle with respect to the what do you call, this one, theta. So this theta will be equals to tan inverse of Fv by Fh. You calculate all these answers. Let me give you the answers. I will just share the answers with you so that you can verify it. So total Fh that you should get, total horizontal force should be equals to 627840. Total Fh that you should get is 627840. Then Fv, net vertical force that you should get, is 493104.2 newtons. This will give you resultant force of 798,332.6 Newton, and that angle theta was 38.14 degrees. These should be your answers. Just verify it once. This is for your self-study. Thank you so much. I hope you are understanding how to solve the numericals based on the hydrostatic law on the curved surfaces. Thank you. See you in the next class.